Okay. So all the definitions are coming under standard condition of temperature and pressure. Okay, and the standard conditions are 1 atm of the pressure, 1 mole per dm cube of the concentration, and 298 Kelvin of temperature. And what are we studying? By the way, we are studying the energetics. This is the first chapter of thermodynamics, and it is belonging to unit 2. Okay, so basic definitions which we are going to work on will be the enthalpy change of formation, enthalpy change of combustion, ionization enthalpy, electron affinity, enthalpy change of atomization, hydration enthalpy, enthalpy of solution, bond dissociation enthalpy, lattice enthalpy of formation, and lattice enthalpy of dissociation. So we'll be working on these ones. And enthalpy of neutralization is also there. I didn't mention it, but we are going to add enthalpy of neutralization also into that. Okay. Now, what is enthalpy change first of all? We'll talk about that. What is enthalpy change? So enthalpy change is basically the change in heat energy or heat transfer. Okay. Yani, when we are working on the chemical reactions, the reactants and products, we will see during these chemical reactions that reactants are going into products. So there will be certain amount of energy needed to break down these, okay, and there will be certain amount of energy which will be released when products are being formed, okay. So the energy released and the energy absorbed during a chemical reaction, we are collectively estimating the difference between these two energies, and we call this an enthalpy change. Actually, that's studied under heat change, right?
Yes.
Okay, so there are different kinds of heat changes or enthalpy changes which we are working on. Okay, so the first one that we are working is enthalpy change of atomization or atomization. um, when you're atomizing something, this process is actually sorry, not the atomization. Where is the atomization? This is the atomization. Okay, we are atomizing something. So when you're atomizing something, you're basically providing heat energy to it, and this process will be actually how we are going to do the definition. First of all, we need to understand that the definitions are under standard temperature, pressure, and concentration. You should keep this in your mind, okay? All the definitions are under standard temperature, pressure, and concentration, 1 mole per dm cube. And when we are working on any enthalpy, it should be for 1 mole, either products or reactants, 1 mole all the time. Okay.
Yes.
See here I've written for 1 mole and under these conditions. Okay. Now let us work on this one, enthalpy of formation. First of all, formation is always exothermic. Keep that in your mind. I've written here exothermic, so negative value will be there. And how I'm going to define it, this is the enthalpy change when 1 mole of a substance is formed. When 1 mole of a substance is formed from its constituent elements with all substances in their standard state under STP, right? This process is exothermic for most of the substances. You getting my point? So the highlighted areas, they are required by the examiner actually. Now see how I'm going to make the definition. It is formation, okay? So formation is for this substance. 1 mole of sodium oxide is being formed from the constituent elements under their standard condition. Now standard condition for sodium is solid and for oxygen it is gaseous state. And the definition is totally based for 1 mole of this substance. Now the equation will be balanced for this substance only, okay? So when I'm writing the equation, it should only be for this substance. You getting my point?
Yes.
Okay. Now if we are working on the formation of H2O, see H2O, 1 mole of H2O is being formed here. Everything should be 1 mole. The definitions are based on 1 mole, okay? And if I am writing for the formation, so formation of 1 mole of water needs how many moles of oxygen and how many moles of hydrogen? So see, half mole of oxygen in gaseous state standard, and 1 mole of hydrogen is needed for it. That will make 1 mole of water. Clear with this?
Yes.
Okay. I'm recording this session also, so it will be uploaded on my YouTube channel, okay? Just watch it there then later on if you don't understand. Enthalpy of combustion now. Combustion means burning something in the presence of oxygen, right? So if I'm burning something in the presence of oxygen, you know that heat is released out. A lot amount of heat energy is released out during burning process, right? So enthalpy change when 1 mole of a substance undergoes complete combustion. Now here you can understand the word complete combustion. It means nothing should be left behind. It should be in the excess of oxygen. Combustion are two types. There's a complete combustion and there's an incomplete combustion. In the complete combustion, carbon dioxide and water is being formed. In the incomplete combustion, carbon monoxide, carbon soot, and water is formed. The amount of energy released in the complete combustion is more, and the amount of energy released in the incomplete combustion is less. So, with all substances in standard states under STP, I'm writing under STP, everything has to happen under these conditions: temperature, pressure, and concentration. This process is exothermic all the time. And if I burn hydrogen, see there, 1 mole of hydrogen is burned now, and the equation is balanced for 1 mole of burning of hydrogen actually. Are you getting my point?
Yes.
Okay. The same is for 1 mole of nitrogen if it is being reacted with oxygen, full oxygen. So it's just the equation which we need to understand first of all. 1 mole of the substance. So now you will be having the question first of all related to the definition. You will do the definition. Secondly, they will give you equations. 4 different types of equation will be provided to you in the MCQs, and you're going to choose the correct equation actually. So the if you're good in choosing the correct equation, then you will only get marks. Otherwise, you won't be able to get marks out of that. Okay, they will give you several different with multiple different numbers of the equation, and all of them will be balanced also. But the one that is for according to the definition, you will go for that equation. Any question to this? Do you have any question? Farhan, any question? Okay. Ionization enthalpy now. Now, when we are ionizing something, basically we are providing heat energy to that substance. Okay. So that's why I've written an endothermic process, positive. The first ionization energy, yani ionization energy can be classified into first, second, and third ionization energy, and so on. There can be many ionization energies, as you have already studied. You people have already studied this in Unit 1. Okay. The first ionization energy is the enthalpy change when 1 mole of a gaseous atom loses 1 mole of electrons, 1 electron per atom, or 1 mole of electrons, okay, to produce 1 mole of gaseous cation with a +1 charge on it, and this will happen under STP. Okay, now you can see the endothermic reaction. The process is endothermic. Now for magnesium in the gaseous state, see the state is different now. Gaseous state will lose 1 electron and will change into magnesium +1 charge. Now when we go for the second ionization energy, already all these ionization energies are discussed in Unit 1. The second ionization energy is when 1 mole of a gaseous 2 plus ion is produced from 1 mole of gaseous cation with +1 charge on it. This process is also endothermic. Now you can see magnesium. From here we took this magnesium, it is +1 charge, and it is now releasing the second electron and changing into it. So second ionization energy is much more greater in magnitude as compared to the first ionization energy. You have any question?
No, sir.
Okay, so if I'll be working for the third ionization energy of magnesium, how will I do that? I'll take magnesium Mg with 2 plus charge on it now. Okay, now in the gaseous state once again, and I'll be working for it, and it will be changed into Mg3 plus one more electron and gaseous state. So this will be the third ionization energy. Okay, clear?
Yes, sir. Yes.
Okay. Moving on to the electron affinity now. Electron affinity is totally a reverse of the ionization energy. Yani the metals they're losing the electrons and the non-metals they're gaining the electrons. So it is mostly related to the gain of electrons, whether metals you're taking or non-metals you're taking, but there is a gain of electron in it. So when we are gaining the electron, basically the electron is highly energetic, so it has to drop down certain amount of energy and reach to the shell, right? So while it will be reaching to the shell and dropping down that amount of energy, it has to release that amount of energy, right? So the process is exothermic. Okay. So if I'm working on the first electron affinity, is the enthalpy change when 1 mole of gaseous atom gains 1 mole of electron per 1 mole of an atom to produce 1 mole of gaseous negatively charged ion. The process is exothermic for many of the nonmetals. Now we are working on the first ionization, first electron affinity of oxygen. Now oxygen is in the gaseous state here, you can see, and one of the electron is there. It will accept that electron. Now this oxygen will be negatively charged. Okay. When we are moving on to the second ionization energy, second electron affinity is the enthalpy change when 1 mole of gaseous negatively charged ion will accept 1 electron per ion to produce gaseous 2 negatively charged ion. Okay, this one is endothermic because when we are adding the electron, the already negatively charged species will have a force of repulsion. So there will be force of repulsion between these two. To overcome that force of repulsion, we have to provide certain amount of energy, right? That's why the process is getting to be endothermic. So there will be a question about it. Why the first electron affinity is exothermic, but the second one is endothermic. The second one is exothermic. Okay. Why the
Can
first
you
electron
repeat it?
affinity? Why the first electron affinity is exothermic, while the second and third and the fourth one they are endothermic? This is the question. Okay. So the reason for that is that when we are bringing the second electron or the third electron to the already negatively charged ion, there will be a force of repulsion. To overcome that force of repulsion, we have to provide it certain amount of energy. That's why the process is becoming endothermic. Let me repeat the question first once again. The question is saying that why the first electron affinity is always exothermic, but the second and third electron affinities are endothermic in nature. Okay, are we clear? Maybe there,
Yes.
maybe I've written these positive values here. This is negative, okay, and this one is positive. For endothermic, you know that it's positive and negative. Okay,
So the electron affinity also occurs in metals.
see, I'll tell you now. The problem is sometimes we don't understand things easily. See this? Chlorine is a non-metal, right? You give it 1 electron and then it will be changed into Cl negative, right?
Yes, sir.
So the enthalpy involved here is called electron affinity. Now, sodium ion +1 is already positively charged. If you want to give it back the electron, Which process do you think is happening?
That's neutralization, I think.
No, this
It
is
will get
electron
neutral.
affinity. Once again, electron affinity. It's gaining an electron. Electron affinity is related to the gain of electron actually. And ionization energy is related to the loss of electron. That's why I told you that whether metals or non-metals, when there is a gain of electrons, this is the electron affinity. Energy related to the gain of electron is the electron affinity, and energy related to the loss of the electron is ionization energy. Are we clear with this?
Yes, sir.
Okay. So reverse process, if I'm moving, then it is ionization. And even if I'm moving reverse process, then it is the ionization, but loss of electron is actually there in it then, which is not the ionization, but an atom is being formed actually in the process. But the loss of electron is called the ionization, and the gain of electron is called the electron affinity. But the amount of energy involved in it, okay? Because we are studying energetics, so everything related to gain and loss of electrons or any physical changes or any chemical changes which are happening, they are considered under the affinity, they are considered under the enthalpy changes, and enthalpy change is the heat change actually, or the energy change actually. Any question? Okay, now I'm moving to the enthalpy change of atomization now, or atomization. Enthalpy change when 1 mole of gaseous atom is produced from 1 mole of elements in its normal state. Okay, and uh, all these definitions are under STP, standard temperature and pressure. Okay. Okay, one thing more which you need to understand is you will find delta H will be written here and there will be a phi sign on it. This phi sign is for these conditions. If somebody asks you that what does this mean, so you will tell that this means the standard condition of temperature and pressure. And what are those standard conditions of temperature and pressure? One mole per dm cube of the concentration, 1 atm of the pressure, which is 100 kilopascal or 110, 101, sorry, and 298 Kelvin of the temperature is there. Okay, and all the definitions are for 1 mole of these substances. Something is being formed, 1 mole of that substance is formed. If something is reacting, then 1 mole of that substance will react. Any question? Now for the atomization, you need to just look into the atomization now. See here. The definition is very clear and it says enthalpy change when 1 mole of gaseous atom is produced. Now see this, the definition is for 1 mole of this gaseous atom. So the balancing of the equation must be for this gaseous atom. Okay? You cannot write I2 is making 2I gaseous state. The definition will be wrong then. And you're not working according to the thermodynamics then. Yeah, you can do the balancing, no problem. But in thermodynamics, the balancing should be equal to the definition. What you're defining, you should be actually doing that in the equation also. So that's why I was telling you that there will be different types of questions, and those questions will be including all these sort of definitions and the equations also. They will give you the definition, they will ask you choose one of the equation which is exactly compromising with the definition. Are we clear with this point?
Yes, sir.
Okay, so inshallah, in the next class, I'll be discussing with you enthalpy of hydration, enthalpy of solution, bond dissociation enthalpy, a lattice enthalpy of formation, and lattice enthalpy of dissociation, and neutralization enthalpy. That will be the last one. So all these definitions will be finished, then we'll work on certain chemical equations, Hass law, and all the calculations, inshallah. Okay, then I'll be providing you this page also. This page is for you people. Okay, any questions so far? You can ask me right now. We have a couple of minutes, so I want to to know about these questions if you have. And if you don't have any question, I want someone to define the enthalpy change of formation for me. No question? Okay. So this recording will be uploaded on my YouTube